Hello, good day. And in this class, we are going to look at something very interesting. We're going to look at introduction to modular arithmetic. Now, by modular, simply means that something is restricted to a certain degree or adjusted to a certain extent. Now, if you look at the board, when we divide an integers, an integer, they are either positive or negative whole number, which also include 0. So when we divide an integer by, say, a number a, now the highest or the possible remainders will be 0, 1, 2, dot, 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 till a minus 1. So if we are dividing an integer by, let's say, 5, the set of value in form of remainder will be 0, 1, 2, 3, and 4. That means we are operating in modulo 5. So the highest possible set of remainder that will occur in 5, if 5 is the divisor, is going to be 0 to 4. Okay. Now, the possible remainder will be 0, like I said, if we're operating in modulo 5, 0, 1, 2, 3, and 4. So when an integer is reduced to these sets, 0, 1, 2, 3, and 4, we can say that we are operating in modulo 5. We can say we are operating in what? In modulo 5. Now let us consider the diagram below. We can use this to carry out addition in clockwise direction and subtraction in anti-clockwise direction. So we are looking at the introduction to modular arithmetic. So like I have explained, for instance, if we are operating in modulo 2, so the highest possible set we can get in modulo 2 is 0 and 1. So in modulo 3 will be 0, 1, 2, 3, so on and so forth, like I've said. Alright. Now, if we are operating this diagram will help us to manipulate or to operate questions on modular arithmetic. Okay, if we look at the diagram here, we have a set of 0, 1, 2, 3, 4. That means we are basically operating in modulo 5. Okay. So let's look at this question. We have 3 plus 7 is equal to congruent bots. So let's do this operation now. Now if we're having 3 plus 7 here, what would you usually do here? You can start on 3. But there's no 7 here now, so you start on 3 and you count 7 times. So we start here. Let's count 7 times to see 1, 2, 3, 4, 5, 6, 7. See, our answer will be what? 0 modulo 5. Okay. So normally 7 plus 3 will give us 10. Now in modular arithmetic, we are more concerned about the remainder, not the number of times such divisor will go into that number. We are more concerned about what? The remainder. So if we say 3 plus 7, normally it will give us 10. If we ask ourselves, how many times will 5 go into 10? And what will be the remainder? So 5 will go into 10 2 times, but the remainder will be 0. So we are more concerned here with the remainder. So in modular arithmetic, we are more concerned about the remainder. not the number of times a particular number will go into an integer. Okay, now let's look at this 2 minus 5 here. So here, because we are operating in minus, so we stand at 2. Like I said, if we're operating in minus, you're going to count in anti-clockwise direction. This clockwise, then anti-clockwise. We'll count 5 times. We'll count here 1, 2, 3, 4, 5. So our answer will still be 2 modulo 5. Okay. So normally, if you say 2 minus 5, what will eventually happen is minus 3. Because we're operating, we don't want to see because we're operating in what modulo 5, we now say plus 5. So 5 minus 3 plus 5 will definitely also give us 2. Okay, simple as that. All right. Okay, let's look at the 4 modulo 4 minus 6. Okay, 4 minus 6. So if we will not start at 4, then we are going to count in what? Anti-clockwise direction. We are going to count this way. So we stand here 4. Your clock, this is clockwise. So 4, count 6. 1, 2, 3, 4, 5, 6. Okay. So our answer will be 3 modulo 5. Okay, look at this. 16 plus 15, and those they are not here. So how do we manipulate this? Very simple. So we are looking at remainder here. So we're going to see how many 5 are contained in 16 and the remainder. So we have 3 5 and the remainder is 1. So we're going to say this is 1. So how many 5 are contained here? I know we are more concerned about the remainder, and remainder is what? Is 0. So 1 plus 0 is what? 1. So our answer will be what? 1 modulo 5. Okay. Now, like this, if we say this plus this is what? 16 plus 15, that will give us 31. So we're going to ask ourselves, how many group of 5 are there in 31 and the remainder? We are more concerned just the remainder. So we're going to have 6 group of 5 there, and our remainder is 1. So we usually pick the remainder, so it's going to give us 1 modulo what? 5. So that's another way you can do it. Okay. Then now we have here, we have a 1 minus 5 plus 2. It becomes equal to what? So first thing we do, we can say that 5. So now there's no 5 here. So what we do here, we say 1. So use our basic operation here, 1. So you can do this first. Okay. Alright, so 1 plus 2. So you start at 1. Then you count 2 times. 1, 2. So it will now be, this one will now be 3. So here, you stand here, you're going to count anti-clockwise 5 times. 1, 2, 3, 4, 5. So our answer will be what? 3 modulo 5. Or if we want to do it, 1 modulo 5, 1 minus 5, here we can say 1, 2, 3, 4, 5. It will be 1. So this our 2 here. We count it again. 1. This is 1, 2. You see, our answer will see the same. Okay. This is just an introductory part to modular arithmetic. In our next video, I'll bring more questions. I'll look at them, more complex questions than this. We'll look at them in details. So but modular arithmetic is all about remainder. The remainder is more concerned about the remainder, not the number of times the number will go into an integers. It's all about the remainder. So stay calm. In our next video, please help me subscribe. And if you also need online classes, virtual classes in mathematics, you can as well get across to me. Have a nice time.